Thank you, Jim, and good morning, everyone. It's actually a little bit daunting to get up here after listening to somebody who's saving lives with 3D printing to talk about industrial 3D printing, but I'll do my best to try to say something that you may walk away with. I'm really honored that Jim and Duncan and the people at Rapid News asked me to speak to you today. As Jim said, I've spent my entire life in the world of manufacturing technology on the industrial side. So when we began thinking about what I might talk about today, we came up with the operational title of 3DP is necessary but not sufficient to realize blah, blah, blah. Now you know that Jim came up with this title because if I had done it, realize would be spelled the correct way with a Z in it and not an S. But nonetheless, that was the working title. But still, since the time that I talked to Jim about speaking here today, I've attended a couple technical presentations, and I attended the International Manufacturing Technology Show in Chicago. Did anybody here go to IMTS in Chicago? Did you have a chance to go? Perfect. Thank you. Well, first up, how many of you have ever heard of 3D printing? You know, it's funny because this is the part where you think if you raise your hand, I might come down and ask you a question, and so somebody says, I'm not going to raise my hand, you know. I think probably everybody has heard of that. Not many people have heard of the International Manufacturing Technology Show, but my attendance there changed completely my view of what I wanted to talk about this morning. So I'm not going to talk about this, although I'm going to get back to the Internet of Things at the end of it. Rather, what I'd like to talk about today is the reality of dynamic digital manufacturing technologies today. Now, how many of you have heard of dynamic digital manufacturing technologies? Good, because I made that up on the plane on the way over, and if you'd heard of it, you'd be sitting next to me or something, I'm not sure. When I begin to think about manufacturing technology, and understand now I've been doing this for almost 40 years, so I was at Gleason Corporation when we introduced the first Bendix machine that had a tape reader on it, that actually made the machine do something other than the operator spinning something or turning something. So I was there when the very, very first ideas of digitized manufacturing began. And back in those days, the late 70s and the early 80s, manufacturing, I think if we look at the metrics of what we measure in manufacturing, we'd all agree manufacturing was probably not great. Productivity was pretty low, quality was not that good, throughput was awful, resource consumption was amazingly high to produce a given amount of product. But we were able in the 1970s and 80s to begin to articulate this vision, the optimization journey. So it begins with a pre-existing state. Let's say in the 1970s or 80s, it was where we were, low productivity, low quality, high resource consumption. Today, we would say we've made a lot of progress, but in those days, people like Joseph Duran and Dr. Deming and Professor Ono at Toyota began to articulate this vision of optimization. So, what is the optimal state in manufacturing? And I think what I would say is that, well, the moment that a consumer wants something, you were able to materialize exactly what they wanted, exactly at the moment they wanted it, exactly where they wanted it. That would be optimal, right? So when we began talking about the Toyota production system and waste that was in the production stream, it wasn't about getting incrementally 2% or 5% better. It was about visioning this thing called the optimal state. So when we think about the optimal state, what is it we're optimizing? Well, manufacturing. Well, what's manufacturing? I think, in my head, manufacturing is sort of a three-step process. We start at the moment of conception when an individual says, I'm going to need to make this, whatever this is. I mean, the gentlemen on the stage here were miraculously good at articulating, wow, what if we could put a pump in your arm that would bypass your heart? Amazing stuff. But manufacturing begins when we conceptualize something. Next step, materialization. So we've conceptualized it. Now how do we actually make this thing we've got in our head? But manufacturing doesn't end at materialization. If we want to think about the optimal state that we've talked about, we have to think all the way to utilization, right? So it's the point in time where a consumer actually uses something and eventually discards it. So the manufacturing cycle begins with an engineer who thinks about an idea and really ends when that product is thrown away and hopefully recycled or used for some other purpose. So when I think about this question of the optimal state, I'm thinking about this entire process stream, conceptualization through utilization. And this is why going to IMTS changed everything I wanted to talk about today, because I'm really understood all this stuff for a long time. In fact, a lot of people understood it. We got really good for a long time at having silos of activities that were interconnected, and they worked synchronously with each other to cause products to be produced. We got really good at it. I mean, if you've ever been in an automotive factory and you watch how it works, it's amazing. When you look at the amount of material, the amount of people, the processes that are going on, it's incredible. But for the most part, there are individual processes that have been somehow interlinked with other individual processes to cause an outcome. And what I saw in Chicago really confused me. And it's the coming of the digital age that has confused me so much. I always saw manufacturing as an integrated, living, breathing thing that all worked together. But I always understood that, well, if an engineer had the problem of, let's say, I want to do this operation, it was pretty straightforward. I need to put a long bore through a part that's true within a thousandths over its length, it's got a surface finish of 20 microns and whatever you need. And so he had 4 choices. I could do it this way, this way, this way, or this way. Go to the 4 companies, get 4 quotes, compare the color and the price and the speed and the accuracy and say, that's the one I want, and you buy it and you put it in and you do your operation. That makes sense to me because I've seen this done for a very long time. So I'm at IMTS in Chicago, and I've lived a long time thinking this way. And by the way, I ran a 3D printing company for 10 years, so you'd think I would get it better than this. But what I saw when I was there was the coming of the digital age has transformed the way we think about how we make things. And I know that's a really self-evident statement, but I want to explore it a bit deeper because I think that's actually the point of where we're going. And as I was flying over, I was flipping through some stuff, and I had done some reading, and I had the Davos World Economic Forum jobs report, and I read through it. And I only took one quote from it because I'm sitting there on the plane, and everybody else is asleep, and I'm going, wake up, everybody. Look, there's something really important right in front of me, okay? We're at the beginning of the 4th Industrial Revolution. 65% of children entering primary school today will end up working in completely new job types that do not yet exist. 2 out of 3 kids entering primary school today are going to work in job types that we haven't invented yet. So I go to Chicago, I see a lot of digital stuff, I get confused, I read this thing and I think, what should I say to a group of people gathered on a Wednesday morning in Birmingham that might want to listen to how technology fits the industrial scene? So, we have this pre-existing state and we have this optimal state. I have lived through, in my eyes, 3 separate stages of evolution toward optimization. The first stage, and by the way, I did all my own slides. Like I did all these curvy things and all that stuff. So anytime you want to like go, wow, that's cool, that make me feel better, okay? Because I'm really not very good at this. I lived through the stage of analog manufacturing. And let's say we start here in the 70s and 80s. We've got analog tools available to us. We optimize those tools. We have quality circles, and we do lean manufacturing, we do Kaizen events, and we reduce waste, and we come up with U-shaped layouts, and we combine operations, and we do all these amazing things that increase productivity, they lower costs, they improve quality. But at some point in time, the ability to improve with that set of tools begins to diminish. We're on a diminishing curve of improvement. And that happened. Well, what happens next? Another set of tools become available to us. Now, eventually, these tools that I call the static digital tools are going to take us closer to this optimal state. But at the beginning, they're actually less effective at solutions than the tools we have in place. And it takes a leap of faith to say, let's put in a CAD system where we do digital design. Oh, wait a second. The old stuff works pretty good. I'm not sure we want to try that. Let's give it a try. But in fact, the first stages of digital manufacturing were analog. They were digital, but they were static. We didn't know how to harness the power of them. But we went through a stage where we had these static digital tools, and we got better again. We used them, we increased productivity, we lowered costs, we improved quality, we improved throughput, we used less resources. But eventually, the ability of those tools to help us begins to taper out. There's only so many Kaizen events you can have and so many ways you can improve that set of tools to get better. And we're still not at the optimal state. So where are we today? I think that what I saw in Chicago is the advent for the first time of dynamic digital manufacturing. For the first time, we're discovering the power of creating linkages between all of these steps that previously were siloed and being able to exploit the connections between them. And again, that seems self-evident. And I know because I've read it, I've seen it said, but I observed it. And I'm going to tell you a couple examples of what I saw that actually kind of stopped me in my tracks. And one was actually sort of funny, but I think we are now in the stage of what I would call dynamic digital manufacturing. And where are we in that stage? Well, in many cases, we're still here, right? 3D printing is a big part of it, but only part. So what are the criticisms of 3D printing? It's slow. Compared to high-speed traditional manufacturing processes, 3D printing is slow. True. On the other hand, most 3D printing processes are 10 times faster than they were 3 years ago. And what is the limit? We don't know. So we're on this curve of discovery. 3D printing doesn't have the material sets that we need. We need every material possible, and that's one reason 3D printing is not very good. Okay, let's look at the material sets we had available 3 years ago. Let's look at the material sets we have available today. Again, we're in this period of discovery and improvement. Yeah, but you can only 3D print things that are small. You can't make big things with 3D printing. Well, in Chicago, Oak Ridge Labs showed a 3D printed house. And I don't mean they made a bunch of pieces and stuck them together. They took a gantry mill, put an extrusion head on the top of it, and they 3D printed out of nylon, silicone reinforced nylon, they 3D printed a house that was 8 feet wide, 10 feet high, and 20 feet long in one piece. They 3D printed an entire body of a Jeep and put it on a Jeep in Chicago. So is it true that 3D printing historically has been for relatively small things? Of course. But if we try to judge what 3D printing may mean to the world by where we are today, we're making a mistake. We have to extrapolate our thinking and say, what can it be? What will it be when it is much faster, the material sets are better, the sizes are better? Then it becomes a real game changer. So back to this question of my confusion in Chicago. I had the opportunity to be there for 6 days, and so I saw a lot of the show. It's a big show, and there's a lot of stuff going on. I walked in a booth, and the booth was run by a robotics company. And they were showing a 3D printer. A robotics company, 3D printer. And I say, robotics company, why are you showing a 3D printer? And they said, you have to understand, the hardest part of 3D printing is positioning. Accuracy of positioning. I can go on the internet and I can get software, I can get a 3D printer, I can get material, I can get all that stuff for cheap on the internet. But what the real key to 3D printing is the exact location of the particulate that you're trying to 3D print. And I walked away, I was impressed. I walked about 100 feet to a 3D printing company who was showing a 3D printer with a robotic arm. And I say, 3D printing company, you've got a robotic arm on your 3D printer, and they say, hey, we can use anybody's robots. I can buy positioning on the internet for a few bucks. Anybody can position accurately. The key to 3D printing is the 3D printing process. I walk another 100 feet and I go to a software company that's showing a 3D printer, and I say, software company, it's amazing you're showing a 3D printer. And they go, 3D printing is easy. I can get a 3D printer anywhere. I go, what about positioning? Positioning's easy. You can buy positioning on the internet. The key to 3D printing is software. So I hearken back to the day when I said, I want to make a hole, and there's 4 companies that can do it, and I know which 4 to ask, and I get 4 quotes, and I compare them, and I buy one, to now, here's an outcome, a 3D printed part. Do you start with the software company? Do you start with the robotics company? Do you start with the 3D printing company? They all get us to the same place because the interconnectivity possible with dynamic digital manufacturing technologies is undiscovered. We haven't found the true path yet, and that's why this is so exciting. I did this slide and did all these squigglies, and you can tell I was on a plane when I did them, but if I think about traditional technology and its evolution, it occurs to me that when a new technology comes onto the market, at first we say it can do anything. And then we try anything, and we discover, well, that didn't really work. That didn't really work. That didn't work. Oh, that worked. That didn't work. That didn't work. That worked. So the amplitude of opportunity starts amazingly wide with a new technology. And over time, it kind of hones down to its exact purpose. This is kind of what happens with technologies. I'm a little confused because I see it going the other way. Almost every day, we're taking this combination of dynamic digital manufacturing technologies, and the opportunity set is getting broader. And that's why this is a really tough question to answer. So I'm going to loop this back to the point of the talk in the first place, which was the Internet of Things. I hope you've heard of the Internet of Things. There's going to come a time in the next 5 to 10 years where most devices are going to be able to broadcast and create feedback. Nearly everything we have is capable of that today. What would happen in a world where we are constantly broadcasting information? Would it actually get us closer to this optimization we talk about? Well, I talked about the cycle of conceptualization, materialization, and utilization. And to me, that's the normal manufacturing cycle. But what would happen in a world where utilization of your product allowed you real-time feedback that could drive conceptualization? What would happen if every time a product failed in the field, the designer who designed it knew about it the second it failed, what would happen? My guess is then we get another step closer to this optimization platform that we continuously talk about. So 3D printing is critical in this process of industrial evolution of technologies. 3D printing alone is not, in the end, the answer. The full integration of all digital technologies, all the steps that you use to make stuff, and the eventual feedback loop that's possible really drives us forward in the future. So I'll tell you one more quick story. I was at a technical conference a few weeks ago, and there's a robotics manufacturer that makes robots using robots. So if you go in their factory, it's a robotized factory making robots. Okay. So they were wondering, and this company is one of the most advanced controls companies in the world, and they were wondering, could we make this factory better? So they engaged some summer interns, and they began taking all of the data that was coming off of their factory floor, all of it, just the big data dump, and turned to these summer interns and said, do some analytics on this. With the improved maintenance cycle that these interns proposed, and these interns had never been on their factory floor, never built a robot, never used a robot, they saved last year, first year, $40 million in productivity on their floor using analytics from the data being produced by the robots that were making robots on their factory floor. The feedback loop possible with the Internet of Things drives conceptualization, and when that happens, our ability to rise to a greater level of productivity and reach that optimal state is enhanced greatly. So I'm excited because I don't think we're at the end of anything. I'm 62 years old, and I'm charged up because we're at the beginning of something amazing. Thank you.